My name is Lillian Buckengroff.
And we are in the Aerospace strand of Governor's Institute of Vermont at University of Vermont.
Our goal was to design a proficient probe to learn more about flight and trajectory motion. We explored velocity and angle to predict ranges through our different iterations.
When starting, we first had the notion of creating a plane powered by a rubber band, like a typical balsa plane, except made with metals available to us. Though a lack of materials to create our propeller changed the motive to making the plane, which we had already constructed into a probe, shot from a handheld air gun. PVC, the original method we used to cover the barrel, was too heavy. So we constructed a shaft out of Gorilla Tape folded over itself for a lightweight alternative. This iteration was shot once, punched the nose, and then we were encouraged to create a drone in the time remaining that we could test for range or hang time.
Our first iteration was designed with a wire mesh body to be lightweight and then covered partway with aluminum foil for aerodynamics. Our wings were solid sheets of aluminum that were heavier than the body, but smooth and without interruption to reduce unwanted drag. We had planned to use industrial rubber bands rigged to a propeller to move our plane, but it quickly became apparent that this would not be feasible and we switched to a launching method. Though PVC pipe, we realized after attaching was much too heavy, and we designed a lighter alternative, which we then launched. It flew, but not smoothly, due to the fact that the mass of our probe was above the location where the thrust was applied, yielding front flips and a crunched nose. We were encouraged to keep the plane intact and move on to testing standard probes.
We made 2 iterations of atmospheric probes from that point, one larger and one smaller, which we tested for range given angle and varying PSI. We had our first probe, heavier and larger, shot at an angle of 85 degrees and at 30 PSI and 40 PSI. Our second probe, which was smaller, was also shot at an angle of 85 degrees at 30 PSI and at 40 PSI.
We found out that our first probe, shot at 45 PSI, had a velocity of 50.031 meters per second and a predicted range of 44.44 meters. Our second probe, shot at 30 PSI, had a velocity of 12.753 meters per second and a predicted range of 28.24 meters. Our second probe, shot at 45 PSI, had a velocity of 36.79 meters per second and a predicted range of 23.98 meters.
Most of the problems we faced with our first iteration plane had to do with the lack of time and materials.
Before continuing further, to gain a larger grasp on what and how to improve our designs, I would spend some time in an introduction class to aerodynamics. Once knowing the basics inside and out, we would probably return to the design of a plane and attempt to make our dream of a metal plane powered by a super rubber band a reality. From then, we can move on to more complex motors and forms of power, and if we dabble in our alternate forms of energy, we would work on planes and high-speed forms of aeronautical travel that will be as energy efficient as possible, made from materials that will not encourage the air that we are flying through to become hostile to lungs and plants.
Through our knowledge of probes and planes is currently limited, engineers around us that would mentor and encourage our growth are thinking as far as designs for probes that can mine asteroids from the asteroid belt to supplement the resources we have on Earth. The world is full of applications for our knowledge, and all that we have left to do is to delve. And all that we have left to do is delve into Okay.
Shall I say that? Okay. The world is full of applications for our knowledge, and all that we have left to do is decide where to delve in and start growing.
Thank you.
Thank you.
Alright.
We can edit that out. But thank you very much.
Really
Yeah.
edit that out?
Yeah.
I don't
On
know about
YouTube. We
editing.
can upload it and we'll just cut it out really fast, and that'll be all the editing that's done. Thank you so much.
No problem. It doesn't want to stop recording.
Was it recording in the first place?
Yeah.
Oh.
4 minutes.
Here, go to here.